September 19th, 1944, 5:30 in the morning. Mist blankets Hill 265 near Arracourt, Lorraine, France. 12 German Panthers wait in ambush. Perfect killing ground geometry. 5 American Shermans roll forward. The Panthers open fire. The fog sits thick across the ridgeline, moisture beading on cold steel. 12 Panther tanks crouch in carefully prepared positions along Hill 265, their long 75mm guns trained on the approach road. The German crews have chosen their ground with precision, open fields of fire stretching 800 meters, defilade positions, hull down behind the military crest. Every commander knows the mathematics. The Panther's WK-42 gun fires armor-piercing rounds at over 1,000 meters per second. Sloped frontal armor 80mm thick, angled at 55 degrees, creating effective thickness of 140mm. The Americans rolling toward them mount 50mm frontal plate and a stubby 75mm gun that struggles to penetrate Panther armor beyond 500 meters. This should be a slaughter. The 5 Shermans from the 37th Tank Battalion emerge from the tree line. Engine noise carries flat across damp earth. The lead tank commander stands in his cupola, searching through the grey morning. He cannot see the Panthers. The Germans can barely see him. The first Panther fires. The round cracks past the lead Sherman's turret, missing by 2 meters. The fog has betrayed the German gunner's optics. What looked like a perfect shot through the rangefinder became guesswork in the mist. The other Panthers open fire. Shells streak through moisture-laden air, their trajectories visible as pressure waves. 2 rounds strike dirt. 1 punches through the fog 20 meters wide. The German tank commanders curse into their throat microphones. Their technological superiority means nothing if they cannot see. The American response comes in seconds. The lead Sherman commander drops into his turret and keys his radio. His voice is calm, procedural, speaking into 2 separate radio sets. One connects him to his platoon. The other reaches battalion fire direction center 3 kilometers behind the line. He calls for smoke. He calls for high explosive. He gives 6-digit grid coordinates while his gunner traverses the turret, hydraulic motors whining. 15 seconds to rotate 360 degrees. The Panther crews turn their turrets by hand when the engine idles, geared so high that full traverse takes over a minute. The Shermans do not retreat. They accelerate. White phosphorus shells begin impacting along the ridgeline. American artillery, already registered on likely ambush positions, delivers smoke on target in under 90 seconds. The chemical fog rolls across German sightlines, adding man-made blindness to nature's. Panther commanders stand higher in their cupolas, squinting, trying to acquire targets that vanished into white haze. Their radio operator in the hull hears frantic chatter, but the Fu-5 radio's limited range means calls for support barely reach the brigade command post 4 kilometers distant. The Shermans split into 2 groups. 3 tanks drive directly into the smoke. 2 swing wide left, using a shallow draw for cover, moving fast across ground the Germans assumed impassable. The fog and smoke become the Americans' friend. They close the distance. 500 meters becomes 300, becomes 150. High explosive shells begin impacting the ridgeline. Not random fire, but precisely plotted concentrations. Multiple batteries arriving simultaneously from different angles. The technique has a name: time on target. Over 100 guns timed, so shells from 15 kilometers away and shells from 8 kilometers away arrive in the same 5-second window. The ground erupts. Concussion waves slam into Panther hulls. Commanders duck into their turrets. Vision blocks crack. 1 tank's radio antenna shears off. The 3 Shermans in the center emerge from smoke at 200 meters. Their guns crack in rapid sequence, not aiming for frontal armor. Aiming at tracks, at vision blocks, at anything that breaks the German tank's ability to see and move. Suppression fire. One Panther's driver, blinded by smoke and concussed by artillery, lurches forward out of his hull-down position, exposing his thinner side armour. The two Shermans on the left flank have reached the base of the hill. They climb the reverse slope. Hydraulic turrets already traversed 90 degrees, guns pointed right. They crest the hill behind the German position. The Panthers' 40 to 50 mm side armour, designed to defeat distant frontal attacks, offers no protection against point-blank flank shots. The first Sherman fires. Armour-piercing round punches through side plate at 120 metres, penetrates the fighting compartment, ignites ammunition. The Panther's turret lifts 3 feet off its ring from internal overpressure. Smoke and flame jet from every hatch. The German crews realise their situation in a heartbeat. Enemy behind them, enemy in front, artillery still falling, smoke everywhere, radios failing. They are being killed by tanks they were supposed to dominate. 5 more Panthers brew up in the next 4 minutes. Side shots, rear shots. One takes a round through the thinner rear deck plating that sets the engine compartment ablaze. Crews bail out, stumbling through smoke, hands raised or running for the tree line. 2 Panthers manage to reverse off the ridgeline and escape. 3 more sit immobilized, tracks blown, crews evacuating. 12 minutes after the first shot, the engagement ends. 8 Panthers destroyed or burning, 4 fled or captured, 5 American Shermans untouched, already repositioning. The German survivors stumble back to their lines with a single coherent thought, burning brighter than the funeral pyres on Hill 265. Everything they believed about tank warfare just died in the fog. The German counteroffensive began 18 hours earlier, in the darkness before dawn on September 18th. Hasso von Manteuffel, commanding the 5th Panzer Army, had received explicit orders from Berlin. Retake Arracourt. Sever the American supply lines stretching east toward the Rhine. Stop Patton's Third Army before it could threaten the Siegfried Line. The plan looked perfect on paper. 2 fresh panzer brigades, the 111th and 113th, equipped with the newest Panthers rolling off production lines in Germany. Nearly 260 armoured fighting vehicles concentrated for a single thrust. The fog that blanketed Lorraine on the morning of the 18th seemed a gift from Providence. It grounded American aircraft. It shortened engagement ranges where German optical superiority might have dominated. It gave the panzers cover to assemble in the rolling farmland east of Arracourt without being spotted by the relentless Allied air reconnaissance that had plagued every German movement since Normandy. But fog is an impartial mistress. Across the line, the American 4th Armoured Division waited. Not in prepared positions, not dug in for defence, but coiled for exploitation. This division had led Patton's charge across France. They had liberated Avranches, taken Troyes, crossed the Moselle. Their commander, Major General John Wood, believed in speed and violence. His subordinates, men like Colonel Bruce Clark and Lieutenant Colonel Creighton Abrams, commanding Combat Command A and the 37th Tank Battalion, had internalized a different philosophy of armoured warfare than their German counterparts. The Germans believed in the platform. The Panther represented the apex of that belief. Superior gun, superior armour, superior optics. Doctrine emphasized long-range gunnery, prepared positions, carefully controlled fields of fire. Tank commanders were trained to think in terms of vehicle versus vehicle duels. Kill ratios, penetration tables, armour angles. The Panther was designed to win that fight, and in a straight duel at 800 metres on open ground, it would. The Americans believed in the system. Their doctrine did not centre on the tank. It centred on combined arms integration. Artillery was not supporting the tanks. Artillery was part of the tank attack. Air power was not overhead assistance. Air power was a synchronized element, timed to suppress and disrupt moments before armour closed. Tank destroyers were not defensive insurance. They were offensive hunters, positioned to exploit flanks the Shermans created. Infantry, engineers, reconnaissance cavalry, forward observers, all integrated into a seamless operational framework where information flowed constantly and fires arrived with mechanical precision. The Sherman tank itself embodied this philosophy. It was not designed to win duels. It was designed to be maintainable, reliable, numerous, and networked. Every Sherman carried 2 radios, one for the platoon net, one for the command net. Crews could call artillery directly. They could coordinate with adjacent units. They could transmit contact reports that reached division headquarters in minutes, not hours. The hydraulic turret traverse gave them speed in engagement, but, more importantly, speed in target switching. 15 seconds to spin completely around meant a Sherman could engage, suppress, reorient, and engage again, while a Panther crew was still hand-cranking their turret toward the second threat. German tanks typically mounted one radio, often with limited range. The Fu-5 set could barely transmit 2 miles. Command and control depended on visual signals, on radio relay through higher headquarters, on rigid pre-planned coordination that shattered the moment contact disrupted the plan. When a German battalion commander's tank took a hit, the entire formation often went silent, leaderless, unable to adapt. This was the collision waiting to happen at Arracourt. Not just 12 Panthers against 5 Shermans on a foggy hill. 2 entire philosophies of mechanized warfare meeting in the mud and rain of eastern France. The Germans brought technical excellence. The Americans brought institutional integration. The Hill 265 engagement was simply the first time the difference became violently, undeniably clear. By noon on September 19th, the reports flooding into German 5th Panzer Army headquarters painted a picture that made no tactical sense. 49 armoured fighting vehicles destroyed or abandoned. 49 in a single morning. The 111th Panzer Brigade had driven into what should have been clean exploitation and instead found themselves fighting for survival against an enemy that materialized from every direction at once. The Americans had not simply repelled an attack, they had orchestrated systematic destruction. The killing began with geometry, but it was perfected with coordination. When the next German assault came on September 20th, larger and more determined, the pattern from Hill 265 repeated across a wider front. Panther companies advanced toward American positions near the villages east of Arracourt. Engines roaring, commanders confident that yesterday's disaster was aberration. American forward observers saw them first. Cavalry scouts in jeeps, positioned on high ground 2 kilometers ahead of the tank line, watched the German columns moving through morning haze. They keyed their radios. Simple contact reports. Direction, estimated strength, rate of movement. The information flowed back through Combat Command A headquarters, where fire direction centers had already plotted defensive concentrations on every likely avenue of approach. The artillery response came before the Panthers entered effective gun range. Time on target. The phrase sounds technical, almost bureaucratic, but the reality was mathematical violence. American doctrine had refined artillery coordination to a science. Multiple batteries, spread across kilometers of rear area, fired at slightly different times, their shells following slightly different trajectories, all calculated so rounds arrived at the target in the same 5-second window. A battery 15 kilometers away fired first. A battery 8 kilometers away fired seconds later. A battery 12 kilometers away split the difference. The Panthers rolled forward into a horizon that suddenly erupted. High explosive shells impacted in continuous ripples of detonation, not a barrage that built gradually, giving crews time to button up and take cover. An instantaneous storm of steel and explosive that transformed open farmland into a hellscape of dirt geysers and shrapnel clouds. Over 100 guns, firing in coordination, delivering tonnage that had been pre-registered, pre-calculated, waiting only for the radio call to release. German commanders, standing in their cupolas for better visibility, dove for their hatches. Radio antennas snapped. Vision blocks cracked from concussion. Tracks through links. One Panther took a direct hit that cracked its engine deck, rupturing cooling systems. Another veered into a ditch, driver blinded by dirt and smoke. The formation scattered, lost cohesion, individual tanks hunting for cover in terrain that offered none. Then the Shermans appeared. Not charging directly into German guns, but working the flanks using draws and tree lines that cavalry scouts had mapped. Platoons moved in bounds. One element fired, suppressing a German position, while another maneuvered. The hydraulic turrets tracked constantly. Gunners did not wait for perfect killing shots. They fired to suppress, to force Panther crews to button up, to degrade their ability to see and coordinate. And through it all, the radios never stopped. Every American tank had two sets. The platoon net crackled with fire commands and movement orders. The command net carried target updates and artillery adjustments. Tank commanders talked to forward observers, who talked to fire direction centers, who talked to battalion commanders, who could see the entire battle developing on map boards 3 kilometers behind the line. When a Sherman spotted a German assembly area, coordinates reached artillery batteries in under 60 seconds. When a Panther tried to flank, multiple platoons received warnings simultaneously. German radio nets, by contrast, fragmented under pressure. The Fu-5 radios had range limitations that doctrine tried to compensate for through relay stations and command vehicles. But relay stations became priority targets. Command vehicles, when hit, created silence rather than flexible command. German battalion commanders tried to coordinate by firing coloured flares, by sending motorcycle messengers, by pre-briefed sequences that assumed the enemy would cooperate. The Americans did not cooperate. They called more artillery. They shifted axes of advance mid-battle. They brought tank destroyers forward to exploit gaps the Shermans created. The 704th Tank Destroyer Battalion, equipped with towed 3-inch guns and lighter M10 destroyers, set ambushes on German withdrawal routes. Panthers trying to disengage found themselves taking flank fire from positions that had not existed 10 minutes earlier. By nightfall on September 20th, the German offensive had stalled, not from lack of courage or individual crew skill. German tankers fought with desperate professionalism, but they fought as individual vehicles or small groups, isolated by artillery, confused by smoke, unable to mass firepower or coordinate movements. The Americans fought as a system, every element linked by radio, supported by fires, informed by reconnaissance, backed by logistics that kept ammunition flowing and damaged vehicles returning to action. The Panther remained superior in technical specifications. But specifications meant nothing when the enemy knew where you were, had artillery plotted on your position, and could coordinate 3 platoons and 2 artillery battalions to converge on you within minutes. September 19th had been a revelation. September 20th was confirmation. The German doctrine was not just failing, it was obsolete. And the men dying in burning Panthers were paying the price for that obsolescence with their lives. September 21st dawned clear and cold across Lorraine. The fog that had cloaked the German advance for 3 days burned away under morning Sunday. Weather reconnaissance flights radioed back to 19th Tactical Air Command, ceiling unlimited, visibility 10 miles, winds light and variable. Fighter-bomber squadrons at forward airstrips received the alert they had been waiting for. Engines coughed to life. Ordnance crews loaded 500-pound bombs and 5-inch rockets onto wing racks. The sky was about to enter the battle. The P-47 Thunderbolt was not an elegant aircraft. It was a 7-ton brute, powered by a massive radial engine that could absorb punishment and keep flying. Pilots called it the Jug. It could carry bomb loads that matched light bombers. It could dive at speeds that tore wings off lighter fighters. And it could loiter over the battlefield for hours, orbiting until forward air controllers called them down onto targets. Those controllers rode in Sherman tanks. The integration of air and ground was not improvised. It was doctrinal, practiced, refined through months of combat since Normandy. Each armoured column included forward air control parties equipped with radio sets that could talk directly to aircraft overhead. They carried coloured smoke grenades, fabric panels in fluorescent orange and pink, anything to mark friendly positions and guide strikes onto enemy concentrations. The system worked because everyone spoke the same language, used the same map grid coordinates. When the first thunderbolts arrived over Arracourt at mid-morning, the German columns were already visible from altitude. Panthers and half-tracks moving in formation, trying to concentrate for another assault. The lead pilot called down to the ground controller. Grid coordinates confirmed. Friendly positions marked with orange panels. Target: armoured vehicles in the open 2 kilometers east. The thunderbolts rolled into their attack dives. Acceleration pulled the airframes past 400 miles per hour. The ground rushed up, details sharpening from vague shapes into individual vehicles. Pilots pickled their bombs at 2,000 feet and pulled out hard. 500-pound bombs tumbled toward Earth, fins stabilizing their fall. They impacted among the German column in geysers of dirt and flame. One Panther took a direct hit that crushed its turret down into the hull. Another had its tracks blown off, immobilized instantly. The thunderbolts came around for rocket runs. 5-inch high-velocity aircraft rockets streaked from wing rails trailing smoke. They were not precision weapons. They were area saturation tools, delivering high explosive across wide zones. German crews bailed from vehicles, running for tree lines, diving into ditches. Command and control evaporated. Officers could not rally units under air attack. Radio discipline collapsed into frantic calls for help that air defense units could not answer. The attacks came in waves throughout the day. 4 aircraft, 6 aircraft, 8 aircraft at a time, working methodically through target lists radioed up from forward observers. Assembly areas, supply dumps, command posts identified by antenna farms, routes marked by fresh track scars in muddy fields. The 19th Tactical Air Command flew sortie after sortie, aircraft landing to refuel and rearm, pilots grabbing coffee and sandwiches, taking off again within 30 minutes. One pilot, Major Charles Carpenter, became legend that day for reasons that defied regulation. Carpenter flew an L-4 Cub, a tiny fabric-covered observation aircraft normally used for artillery spotting. He had somehow mounted bazookas under his wings. 6 tubes per side, loaded with anti-tank rockets meant for infantry use. When he spotted German armour, he dove his fragile aircraft at targets and launched his improvised ordnance. He claimed multiple vehicle kills. Carpenter radioed back to base. Word must be getting around to watch out for Cubs with bazookas on them. By sunset on September 21st, the German command structure had taken casualties it could not afford. Battalion commanders killed in strafing runs, company officers wounded evacuating burning vehicles. Communication networks disrupted by destroyed relay stations. The Panthers still outnumbered the Shermans. German crews still possessed skill and courage. But courage means nothing when the enemy owns the sky and uses it with industrial efficiency. The Americans had opened a third dimension of warfare. Artillery provided the hammer. Armour provided the anvil. Air power provided the sword that struck anywhere, anytime, without warning. The Germans could hide in fog. They could not hide in clear weather. And the weather forecast for the next week showed nothing but Sunday. The rain began on the night of September 23rd. Not the gentle autumn mist of earlier days, but cold driving sheets that turned roads into rivers of mud and open fields into morasses. By dawn on September 24th, the temperature had dropped below freezing. The ground froze on the surface while remaining soft underneath, creating a treacherous crust that broke under the weight of heavy vehicles. The weather had turned again, but this time it simply revealed which army was built to endure. The Panther was an engineering marvel and a logistical nightmare. Its interleaved road wheel suspension provided superior ride quality and distributed weight efficiently across tracks. But those same overlapping wheels became death traps in Lorraine mud. Wet clay packed between the wheels during the day. At night, temperatures dropped and the mud froze solid, locking the wheels in place. Crews woke to find their tanks immobilized by ice. They lit fires under the bogies, risking detection, trying to thaw the mechanisms. Panthers that had survived American guns sat abandoned on roadsides, defeated by weather and poor design. The final drive and transmission problems grew worse with stress. The Panther's powertrain was overstressed from the beginning. A 500 horsepower engine driving a 45-ton vehicle through complex gear trains that fractured under sustained operation. Transmissions that might have lasted months in garrison failed after days of combat. Final drives, the reduction gears connecting transmission to sprockets, cracked and seized. German mechanics worked through the night in freezing rain, trying to swap components that required specialized tools and lifting equipment they did not have. A Panther engine change required a gantry crane. A transmission replacement meant pulling the entire turret. The Sherman, by contrast, was designed for field maintenance. Master Sergeant John Fulner, a maintenance chief with the 4th Armored Division, described the procedures that kept American tanks fighting. Track repair, 1 hour. Engine swap, 4 hours. Transmission replacement, 6 hours. The Sherman's engine sat on a cradle that could be pulled straight out the back with a simple A-frame hoist. The transmission bolted to the front with standardized flanges. Every component was designed for replacement, not repair. Throw out the broken part, bolt in the new one, return the tank to combat. The parts were there because the logistics system put them there. The Red Ball Express, the legendary truck convoy system, moved 12,000 tons of supplies per day along routes stretching over 300 miles from Normandy beaches to the front lines. Truck drivers drove around the clock in convoys that never stopped. Fuel, ammunition, rations, and spare parts flowed forward in a continuous stream. When a Sherman threw a track, replacement sections arrived within hours. When an engine failed, a rebuilt power plant sat waiting at the division maintenance depot. German logistics had collapsed. Fuel starvation was mathematical certainty. A Panther consumed approximately 2.5 gallons per mile cross-country. A day of manoeuvring could burn through 300 gallons. The German supply system, dependent on horse-drawn wagons and a rail network being demolished by Allied air power, simply could not deliver enough fuel to sustain offensive operations. Ammunition shortages followed. Panthers rationed their main gun rounds. Crews were ordered not to engage unless certain of a kill. Meanwhile, American Shermans fired at will, knowing resupply would arrive before nightfall. The artillery reached a crescendo on September 26th. 15,000 rounds, according to division records. 15,000 shells falling on German positions in a single day. That is 625 rounds per hour. 10 rounds per minute, sustained for 24 hours. It represents coordination across dozens of batteries, supply trucks carrying tonnage from ammunition dumps, fire direction centers, plotting concentrations, forward observers adjusting impact points. The effect was not just physical destruction. The psychological impact broke units. German soldiers lived under a steel umbrella from which there was no escape. Bunkers offered no protection. Movement attracted immediate fire because cavalry observers watched every road. Rest was impossible because the shelling continued through the night. Soldiers stopped sleeping. They stopped eating. Some stopped functioning, sitting in foxholes, staring at nothing. The maintenance asymmetry showed in the availability numbers. American after-action reports claimed approximately 90% of their armor remained operational throughout the Arracourt fighting. Tanks damaged in combat returned to action within days. The Germans saw their operational strength collapse. Panthers that took track damage sat abandoned because recovery vehicles could not reach them. Tanks that broke transmissions could not be repaired forward. The German operational rate dropped below 50%, not primarily from enemy action, but from mechanical attrition and the inability to sustain repairs. The weather, the mud, the cold, all became force multipliers for the side that had built systemic resilience into their equipment and doctrine. The Americans had not designed better tanks. They had designed tanks that could be maintained under field conditions by crews with standardized training, using interchangeable parts delivered by a logistics network that treated maintenance throughput as important as ammunition supply. By September 26th, the German offensive had become a German ordeal. Units held positions they could not supply. They fought with vehicles they could not repair. They watched American tanks maneuver with fuel they did not have. The Panthers, those magnificent machines, sat frozen in mud or limping on broken final drives, while Shermans prowled past them hunting. The arithmetic of attrition is cold and mechanical. 90% availability versus 50% availability does not produce a 2-to-1 advantage. It produces an exponential advantage because the 90% forces can concentrate while the 50% forces fragment. Every day the gap widened. Every day more Panthers became immobile monuments to the failure of platform-centric doctrine against system-centric warfare. The rain continued, the temperature dropped, and the killing continued, methodical and relentless. September 27th brought a new predator to the hunt. The M18 Hellcat was not designed to slug it out with enemy armor in sustained duels. It was designed to kill and disappear. Fast, lightly armored, mounting a 76mm gun that could penetrate a Panther's side armor, the Hellcat embodied a different philosophy of tank destroyer employment. Speed was armor. Mobility was protection. Strike from ambush, fire, displace before the enemy could return fire. The 704th Tank Destroyer Battalion had been waiting for exactly this opportunity. Lieutenant Edwin Leiper's platoon occupied positions along a tree line east of Arracourt, their Hellcats hidden in defilade, only gun barrels visible over the ridge crest. The reconnaissance had been thorough. Cavalry scouts had identified a German supply route, a farm road connecting rear area assembly points to forward positions. Panthers and supply vehicles moved along this route in late afternoon, using lengthening shadows for concealment from air attack. The Americans had watched for 2 days, noting timing, vehicle spacing, typical security elements. The ambush was laid with mechanical precision. 3 Hellcats, positioned in a shallow arc covering 400 meters of road, supporting Shermans 200 meters back, providing overwatch and blocking any German flanking attempt. Artillery forward observer, with direct line of sight and radio, already set to fire direction frequency. Infantry security elements watching the German approach routes. Every man knew his job. Every vehicle knew its escape route. The German column appeared at 1600 hours. 6 Panthers moving in loose formation, followed by half-tracks carrying infantry and supplies. The lead Panthers commander stood in his cupola, scanning the tree lines but seeing nothing. The Americans had camouflaged their positions with cut branches and local vegetation. The Hellcats sat silent, engines idling almost inaudibly, crews watching through sights. Leiper waited until all 6 Panthers were in the kill zone. 300 meters, 250, 200. His gunner tracked the lead vehicle, crosshairs steady on the Panther's side hull where armor was thinnest. Leiper keyed his radio once. A single click transmitted to the other 2 Hellcats. The signal to fire. 3 guns fired simultaneously. The lead Panther took a 76mm round through its side sponson. The shell penetrated clean, detonated inside the fighting compartment. The second Panther, attempting to traverse its turret toward the threat, presented its rear deck to the second Hellcat. Another penetration. Flame erupted from engine louvers. The third Panther's driver panicked and accelerated forward, trying to escape. He drove directly across the third Hellcat's sights, side shot at 180 meters. The round punched through, and the Panther slewed sideways, track blown, crew bailing. The German infantry half-tracks attempted to deploy their troops. Artillery fire arrived 8 seconds later. Pre-plotted concentrations. The half-tracks disintegrated under high explosive impacts. Infantry scattered into fields, pinned by Sherman machine gun fire from overwatch positions. The remaining 3 Panthers tried to return fire, but could not identify targets in the tree line. They fired at muzzle flashes, at suspected positions. Rounds cracked through branches, impacted dirt, missed. The Hellcats were already moving. Reverse 50 meters, shift position laterally, find new firing angle, 12 seconds from shot to displacement. The Panther crews were still traversing their turrets when the Hellcats fired again from new positions. 2 more Panthers destroyed. One managed to reverse behind a stone farm building, using it for cover, but trapped and immobilized by terrain. The 6th Panther fled, engine roaring, throwing mud from its tracks as it raced back down the road. 12 minutes from first shot to last. 8 German armoured vehicles destroyed or disabled. 2 half-tracks wrecked. Estimated 30 casualties among the infantry. American losses, 0. The Hellcats had already displaced to alternate positions a kilometre away, invisible again, waiting for the next opportunity. The engagement demonstrated everything the Germans had failed to understand about American armour doctrine. The tank destroyer was not a defensive weapon. It was an offensive ambush platform, employed with artillery support, integrated reconnaissance, and rehearsed displacement drills. Speed, coordination, and violence overwhelmed technical advantage every time. Hasso von Manteuffel stared at the situation map in his command post and saw catastrophe rendered in red grease pencil. September 27th. 9 days into what was supposed to be a decisive counter-offensive, his 5th Panzer Army had begun the operation with 262 armoured fighting vehicles. The latest reports showed 62 operational. The rest destroyed, damaged beyond field repair, or abandoned for lack of fuel and parts. But Berlin expected results, and Manteuffel was a soldier who followed orders. He planned one final push, not the sweeping offensive he had envisioned, but a concentrated thrust with everything that still moved. Elements of the 11th Panzer Division would attack from the north. The surviving Panthers from the 111th and 113th Brigades would drive from the east. Artillery would support with what little ammunition remained. If they could break the American line, if they could reach the supply dumps at Arracourt, perhaps they could salvage something. The attack began before dawn on September 29th. The Germans moved in darkness, hoping to achieve surprise, hoping the Americans would not have time to coordinate their devastating artillery responses. Panthers rolled forward through morning mist. Commanders remembered that first day, when fog had seemed like an advantage. Now they understood that American doctrine did not depend on perfect visibility. It depended on coordination, and coordination worked in any weather. American cavalry screens detected the movement within minutes. Radio reports flowed back to Combat Command A headquarters. Forward observers plotted concentrations. Artillery batteries received fire missions. The system that had shattered every previous German attack prepared to do so again. The Panther attack broke through the initial American screen positions. Weight of numbers and sheer determination carried them forward 800 meters, 1,000 meters. They overran a forward observer post. They knocked out 2 Shermans caught in the open. For a brief moment, the offensive seemed to achieve something. Then, the artillery arrived. Time on target. The Americans had refined the technique to an art form. This fire mission involved every available battery in range. Shells from 12 kilometers, 8 kilometers, 15 kilometers away, all timed to converge on the German axis of advance in a 5-second window. The bombardment did not just disrupt the attack, it disintegrated it. Panthers took direct hits. Tracks were blown off, vision blocks shattered, commanders standing in cupolas were killed by shrapnel, radio antennas snapped. One Panther's gun barrel was bent by a near miss, rendering it useless. The formation that had maintained cohesion scattered, each tank commander making individual decisions about survival versus mission. The Shermans counterattacked into the chaos. They maneuvered on the flanks, using the ground, using smoke that artillery had laid precisely where needed. Platoons worked in coordination, one element suppressing, while another flanked. The hydraulic turrets traversed constantly, engaging, reorienting, engaging again. German crews, concussed by artillery, blinded by smoke, isolated by failed communications, fought as individuals against a system. The killing was methodical. Panthers disabled by artillery were finished by Sherman flank shots. Panthers attempting withdrawal drove into prepared tank destroyer ambushes. Panthers holding positions were bracketed by artillery and pounded until crews evacuated. By mid-morning, the German thrust had been annihilated. Manteuffel received the reports throughout the morning, each one worse than the last. Battalion commanders killed, company formations shattered, armor strength down to single digits in some units. By noon, he understood what his subordinates had been trying to tell him for days. This battle could not be won. The Americans had not just defeated his tactics. They had rendered his entire operational concept obsolete. The order to withdraw came in early afternoon on September 29th. Not a tactical repositioning, a full withdrawal from the Arracourt sector. The 5th Panzer Army would pull back, consolidate what remained, and defend. The counter-offensive was over. The Germans retreated under continuous artillery fire. American tank destroyers harassed the withdrawal routes. B-47 Thunderbolts struck column after column. What had been an army became a collection of survivors, moving east, abandoning vehicles that broke down, carrying wounded on any transport that still functioned. The Americans did not pursue recklessly. They advanced methodically, clearing positions, securing ground, maintaining the coordination that had won the battle. Combat Command A moved forward to occupy abandoned ground. Engineers cleared routes. Supply trucks brought forward fuel and ammunition. Maintenance crews recovered, damaged Shermans, and began repairs. By sunset on September 29th, the Battle of Arracourt was over. The German counteroffensive had failed completely. Manteuffel's Panthers, the machines that were supposed to restore German armour supremacy, lay burning across the fields of Lorraine. The myth that better tanks win wars had been shattered as thoroughly as the Panthers themselves. And in the twilight, the Shermans stood silent on the ridgelines, battered but operational, ready to continue east. The accountants of war tallied the costs in columns of numbers that told a story more devastating than any tactical narrative. The German 5th Panzer Army had entered the battle with 262 armoured fighting vehicles. When the fighting ended on September 29th, 62 remained operational. 200 Panthers, the most advanced tanks Germany could field, reduced to scrap metal across 12 days of combat. Approximately 200 German armoured fighting vehicles destroyed or damaged beyond repair. The American losses told a different story. 25 Sherman tanks destroyed during the Arracourt fighting. 7 tank destroyers lost. An additional 23 tanks damaged, but returned to service within days. For the entire month of September, across all operations in the sector, the 4th Armoured Division reported 48 tanks lost. Against German losses exceeding 200 vehicles, the exchange ratio defied every prediction based on technical specifications alone. The Ballistic Research Laboratory would later analyze the engagement data and calculate a kill ratio of approximately 3.6 to 1 in favor of the Sherman against the Panther. 3.6 Panther kills for every Sherman lost. The number seemed impossible given the armor and gun differentials, but the number reflected a fundamental truth the Germans had failed to grasp. Tank versus tank combat was not a duel between platforms. It was a test of systems. The human cost could not be reduced to ratios. German casualties ran into the thousands. Tank crews burned alive when ammunition detonated. Infantry caught in artillery barrages. Officers killed by airstrikes and counter-battery fire. The wounded overwhelmed German medical facilities, which lacked the supplies and mobility of their American counterparts. Many wounded German soldiers were captured and treated by American medics alongside their own casualties. American casualties were lighter, but not insignificant. Tankers killed when Panthers achieved perfect shots. Infantry wounded clearing positions. Forward observers hit by German counter-battery fire. Every loss was recorded, every name documented, every family notified. The 4th Armoured Division maintained casualty reporting that was meticulous and honest. The civilian population of Lorraine paid a price that neither army's records adequately captured. Villages became battlefields. Farms were churned to mud by tracked vehicles. Artillery destroyed homes and churches indiscriminately. French civilians caught between armies suffered casualties and displacement. Some villages lost entire generations who had already survived 4 years of occupation, only to die in the crossfire of liberation. The material imbalance extended beyond armor losses. German artillery ammunition expenditure dropped to critical levels by September 26. American artillery fired 15,000 rounds on that single day and continued sustained bombardment throughout the battle. German fuel shortages left operational Panthers immobile. American logistics delivered gasoline without interruption. The disparity in sustainability proved as decisive as any tactical engagement. The Germans lost something more important than vehicles and men. They lost the doctrinal confidence that had sustained them through 5 years of war. The Panther was supposed to be the answer to Allied material superiority. It was supposed to prove that German engineering and tactical skill could overcome American industrial production. Arracourt demonstrated the opposite. American combined arms doctrine had dismantled German armor theory so thoroughly that no amount of technical superiority could compensate. General Hasso von Manteuffel would later write about the battle with bitter honesty. His Panthers had been defeated not by better tanks, but by better coordination. The Americans fought as a single organism. The Germans fought as individual units, attempting coordination. The difference was absolute. The battle ended, but the war continued. The 4th Armoured Division refitted, replaced losses, and prepared to continue the advance. Damaged Shermans were repaired or replaced. Crews rested and integrated replacements. Within a week, the division was ready to fight again. The Germans needed months to reconstitute the shattered panzer brigades. Many Panthers destroyed at Arracourt were irreplaceable. The factories that built them were under increasing air attack. The numbers told the story. The bodies gave it weight. The smoking hulks of Panthers across Lorraine's fields provided the evidence. Platform superiority had lost to systemic superiority. And the doctrine that won at Arracourt would shape American armor employment for generations to come. The victory at Arracourt rested on pillars the Germans never saw. Intelligence, logistics, and medical systems formed an invisible infrastructure that enabled every tactical success. These unglamorous elements of warfare determined outcomes as surely as any tank engagement, yet they operated beyond the awareness of most combatants. Ultra intercepts provided strategic warning that transformed American defensive planning. British cryptanalysts at Bletchley Park had broken German high-level communications, reading messages that revealed operational intentions before German field commanders received their orders. When the 5th Panzer Army prepared its counteroffensive, American intelligence officers knew the approximate timing, the units involved, and the intended axes of attack. This was not tactical intelligence about immediate threats. This was strategic foreknowledge that allowed Combat Command A to position forces, register artillery concentrations, and prepare logistics before the 1st Panther crossed the line of departure. The intelligence fusion extended beyond Ultra. Aerial reconnaissance flights photographed German assembly areas daily. Forward observers and cavalry patrols reported movement in real time. French resistance fighters provided information about German supply routes and headquarters locations. All of this information flowed into division intelligence sections that synthesized tactical and strategic inputs into actionable intelligence. When artillery fired counter-battery missions, they targeted German guns located through sound ranging, flash spotting, and aerial photography. When Thunderbolt struck command posts, they hit coordinates derived from radio direction finding and agent reports. The Germans possessed skilled intelligence officers and capable reconnaissance units, but their intelligence collection was fragmented, their communications compromised, and their ability to distribute information disrupted by Allied air superiority. German commanders fought partially blind, while American commanders operated with near-complete battlefield awareness. The medical system provided a psychological force multiplier that statistics alone could not capture. American tank crews fought with the knowledge that, if they were wounded, help would arrive quickly. Every battalion included medical personnel trained in forward trauma care. Plasma, morphine, and sulfur drugs were distributed down to company level. Jeeps converted to ambulances could evacuate casualties from frontline positions to battalion aid stations within minutes. From there, wounded soldiers moved to mobile surgical units equipped to perform life-saving procedures, hours, not days, after injury. The survival rates reflected this system. American tankers, wounded in combat, had dramatically better chances of survival than their German counterparts. This was not just humanitarian, it was operational. Crews who knew they would receive rapid medical attention fought more aggressively. They took risks that German crews, aware of the primitive state of their own medical evacuation, avoided. The willingness to close with the enemy, to maneuver boldly, to press attacks, stemmed partly from confidence in the medical system that waited behind the lines. German medical services had collapsed under the weight of sustained combat and supply shortages. Wounded soldiers waited hours for evacuation. Medical supplies were critically short. Surgical facilities were overwhelmed and undermanned. The contrast between American and German medical care was as stark as the contrast between their logistics systems. Intelligence provided foresight. Logistics provided sustainability. Medical care provided confidence. Together, these systems created the conditions for tactical success. The Sherman crews who flanked Panthers on Hill 265, the forward observers who called artillery fire, the Hellcat crews who struck and disappeared, all operated within an infrastructure that made victory not just possible, but probable. The Germans brought superior tanks to Arracourt. The Americans brought a superior system. And, in modern warfare, systems prevail. The lessons of Arracourt did not fade with the smoke over Lorraine's fields. They crystallized into doctrine that would shape American armored warfare for generations. The battle became a case study taught at Fort Knox, analyzed in staff colleges, referenced in field manuals. What happened in those 12 September days in 1944 established principles that guided post-war armor development and defined how the United States would fight mechanized wars. The myth of platform superiority died at Arracourt. For years, military theorists had debated whether quality or quantity mattered more in armoured warfare. The Germans had bet everything on quality. The Panther represented that philosophy's apex: superior gun, superior armour, superior optics. On paper, it was the better tank. In combat, it lost decisively. The 3.6 to 1 kill ratio demonstrated that platform specifications meant little when divorced from systemic support. American doctrine absorbed this lesson completely. The Sherman was not celebrated as a great tank. It was recognized as a good enough tank employed within a great system. This distinction became foundational. Future American armor development emphasized reliability, maintainability, standardization, and integration over pure performance specifications. The M48 pattern, the M60, and eventually the Mohn Abrams all reflected this philosophy. They were designed to be maintained in the field, supplied by robust logistics networks, and employed within combined arms teams. The combined arms integration demonstrated at Arracourt became doctrine. Artillery was not supporting fires. Artillery was integrated fires, timed and coordinated with maneuver. Air power was not close air support requested when convenient. Air power was planned and synchronized, with forward air controllers embedded in ground units, speaking the same language, executing rehearsed procedures. Tank destroyers were not defensive reserves. They were offensive hunters employed to exploit opportunities that maneuver created. Time on target became a standard artillery technique taught to every fire direction officer. The principle that multiple batteries could deliver simultaneous fires from different angles created effectiveness that no single battery could achieve. The Germans had skilled artillerists and excellent guns, but they lacked the communication networks, standardized procedures, and logistical depth to mass fires the way the Americans did. That capability became a signature of American military operations through Korea, Vietnam, and beyond. The radio networks that enabled American coordination became the blueprint for future communications architecture. The two radio Sherman, one for command net and one for platoon net, established the principle that tactical units needed multiple simultaneous communication channels. This concept scaled upward. Modern military communications, with their multiple frequency nets and digital data links, are descendants of the FM radio systems that coordinated the Arracourt battle. Maintenance and logistics were elevated from support functions to combat enablers. The realization that 90% availability rates produced exponential advantages over 50% availability fundamentally changed how the military approached equipment design. Parts interchangeability became a requirement. Field maintenance became a design criterion as important as firepower or armor protection. The Red Ball Express model of continuous logistics flow influenced everything from Vietnam-era supply operations to modern logistics planning. The intelligence operations fusion demonstrated at Arracourt, where ultra-intercepts, aerial reconnaissance, and ground reports combined to create near-complete battlefield awareness, became the model for future intelligence support. The concept that intelligence was not a separate staff function, but an integrated element of operations planning defined American military doctrine forward. Lieutenant Colonel Creighton Abrams, who commanded the 37th Tank Battalion at Arracourt, would later become Army Chief of Staff. The main battle tank that replaced the M60 was named in his honor, the Mohn Abrams. The choice was symbolic. Abrams represented the doctrine that Arracourt validated: aggressive maneuver, combined arms, systemic superiority. The tank that bears his name embodies those principles. Arracourt proved that wars are not won by superior weapons. They are won by superior systems. The Panther was a better tank than the Sherman in almost every measurable way. But the Americans built a better army. They trained better, they communicated better, They sustained operations better, they integrated arms better, they adapted faster. The German doctrine, brilliant in its technical execution but rigid in its systemic assumptions, could not compete. Platform-centric warfare lost to system-centric warfare. That lesson, learned in the mud and blood of Lorraine in September 1944, remains valid. It shaped NATO doctrine throughout the Cold War. It influenced the development of air-land battle doctrine. It underlies modern network-centric warfare concepts. The smoking Panthers on Hill 265 taught the lesson. The doctrine that won the peace made it permanent.